Good day, Algebra. We are starting POFitty-Five. You know it's a good one because there's two parts to it. Part one is today. And we've graphed parabolas. We've worked with quadratic equations. You've added them, subtracted them, you've factored them, you've done all these different things with them. And today we're going to start talking about how to solve a quadratic equation. And to solve a quadratic equation, when you see it, what it's referring to is to find the x-intercepts of the parabola. Okay? To find the x-intercepts of a parabola. That's what it means to solve. Right? And essentially, based on what we know about an x-intercept, what's the value of y on every x-intercept point? Zero, right? If it's on the x-axis, there's no up or down movement, it's going to be zero. So what this means to find the x-intercepts is we want to solve for x when y equals 0. Okay? When we say solving a quadratic equation, it means find the x-intercepts. When we say find the x-intercepts, it means we want to solve for x when y equals 0. Okay? And think about what parabolas are. It says the solutions to a quadratic equation on the parabola's x-intercepts. We talked about that. Generally, you'll be looking for two solutions or x-intercepts for a parabola. A parabola has two solutions when it crosses the x-axis twice, right? As most parabolas will. Okay? This would be a solution here. This would be a solution here. It's got two of them, right? If it opens up, crosses it twice. This would be a solution here. This would be a solution here. Okay? What would it look like if a parabola only has one solution? It only crosses the x-axis once. How is that possible? If a parabola goes up and then comes back down again, or goes down and then goes back up again, how could it possibly only cross the x-intercept one time? Garrison?
Maybe one of the last segment was I don't know.
No? Kaylin? That's a good guess. But
Like where like the lowest point is like on the x-axis.
what's that called?
The vertex.
The vertex. If the vertex is on the x-axis, that means it's only going to cross it one time, right? Because if the parabola comes down, touches the x-axis at the vertex point, that's only one touch. It's one solution. Okay? It's not going to come back down and touch it again. If the parabola is opening downward, that vertex is on the x-axis, it's only going to have one solution. It only touches the x-axis one time. Okay? How about if a parabola have no solutions? How is that possible? Eli.
It doesn't even reach the x.
If it doesn't even reach the x-axis, right? A parabola with no solutions would be like if it opens upward, but the vertex is above the x-axis, doesn't make it there, doesn't cross the x-axis, or if it opens downward, if the vertex is below the x-axis. Again, doesn't touch it. So you always have to be looking for two solutions, but sometimes it'll only have one. Sometimes it won't have any. Okay? But you always have to be looking for two of them. Okay? Questions so far? Okay?
We're good.
So if you flip ahead on the pages, you will see that there are three different key points, three different types of equations that we can write. Because if you have a quadratic equation in y equals ax squared plus bx plus c, which term makes the equation quadratic? Ax squared. Okay? If you have a parabola, you have to have the x squared term. But if you eliminate the bx term and just have ax squared plus c, that's still a parabola. It doesn't have the bx term. If you eliminate the c term and just have ax squared plus bx, that's still a parabola. It just doesn't have the c term. Okay? So because there are three different types of quadratic equations, all having the ax squared term, that's what makes them a parabola, there are three different methods that we're going to learn for solving each of them. Okay, one method for each of them. And the first one is if your equation looks like this, ax squared plus c. So there's no bx term. The method is the order of operations. We're starting with this one because it's the one you're most familiar with. You've been solving equations using order of operations since 5th grade probably, right? Only now we're introducing some new operations here. Your solutions, here's your hints, will always be opposite values. 8, negative 8. 10, negative 10. 0.5, negative 0.5. So on a help sheet, you can write this entire part down. You can write for this form of an equation what the method is, and then what's your hint. Okay? You can't put any examples on there, but you can put this information up on the top here. So our first one, y equals 3x squared minus 75. Because we're looking for the x-intercept, what are we setting y equal to? 0. So we can rewrite this to be 0 equals 3x squared minus 75. And we can recognize this as being this form, so it's got the x squared term, and it has the constant, right? It's missing that bx term. That's how we know that we're dealing with order of operations here. And using order of operations, or opposite operations, what would our first step be? Add 75 to both sides. Okay? That's going to cancel the 75 out on the right. And it's going to give us the equation 75 equals 3x squared. What do we do next? Using the opposite operations method. Solving for x. Yeah.
Divide each of them by 3.
Divide by 3. And that gives us 25 equals x squared because those 3's cancel out. And now here's where your quality of life, being a PERMDAS person, is much better than those PEMDAS people. Because the PEMDAS people, they know that addition is the opposite of subtraction. They know that multiplication is the opposite of division. But then they get to that exponent. What do I do now? What's the opposite of an exponent? You being PERMDAS people, you know the answer to that. What is the opposite of an exponent? A radical. So you've not done this before. You've not done this before, but this is the next level of solving equations, order of operations. To undo squaring x, you are going to root x. Okay? To undo squaring x, you are going to root x. And you also have to root the other side as well. Okay? Maddie?
Can I say that?
Sure.
Isn't it?
Okay? So the root of x squared, those operations cancel out, just like all the other ones. And we get 5 equals x. But wait a minute. That's only one solution. We're looking for 2 solutions. Nathan?
-5.
Why -5?
Because you said it was always going to be opposite.
Okay, but why does that mathematically make sense that our answer would both be 5 and -5? Yeah.
Because you're smart and you said so.
Yeah.
Why?
You're smart and you said so.
Well, that may be true. I'm going to prove it to you mathematically. Cool?
Is it absolute value?
Not absolute value here. It has to do with that kind of, but
Because if it would be -5 and multiplying by itself, it would make it 20 positive.
aha. Remember what the definition of a square root is. Something times itself equals 25. 5 times 5 equals 25, but so does -5 times -5 equals a positive 25. Now, when we root things, we don't usually take the negative value, but in the context of a parabola, we need it. Okay, because technically, -5 times itself is going to give you positive 25. So remember, 2 solutions. Your solutions will be opposites on the test. Every year, someone stops here. Multiple people do. Because they forget that, 2 solutions, right? Because that definition of a root, we can see it does give us 2 solutions. Not only is x positive 5, but x is -5 as well. Okay? Now, because mathematicians are always lazy, we're always looking for shortcuts here. Because people didn't want to write both values, we came up with a symbol that takes care of that for us. If you were to write x equals positive and negative 5, that's how you could shorten it up. That plus minus symbol means both positive and negative of whatever the number is. If you want to write them both, like I did here, that's perfect. But you can abbreviate it by using that plus minus symbol there. Right? Maddie?
Doesn't that kind of make like less sense than the X? Like, I don't know. Never mind.
It's just a shorter way to write exactly what we have down at the bottom there.
Oh.
Yeah, that plus.
So that's a sorry.
Yeah, it's an actual thing. Yes, it means the positive and negative value of whatever comes after it. Caitlin? Sure. Any other questions on this? Yeah. Okay. So the only new part here, as far as opposite operations, that method goes, is this last step of rooting both sides here. But again, PERMDAS people, we're just smarter. Okay, we know what to do there. Yes.
Well, how would you get like? I don't know how to word it.
Well, think about it. Let me know. Okay. Next one. Y equals negative 5x squared plus 20. Since we're solving for the x-intercept, we're setting y equal to 0. So 0 equals negative 5x squared plus 20. What's our first step here? Cool.
Minus 20.
Subtract 20 from both sides.
And then.
So we get negative 20 equals negative 5x squared. Colin?
I just have a question about this. It's not in this question, but what if your number, your constant, on the other side?
Does it happen in the next one? I don't think it does.
No, but what if it's negative?
Let's say that. We'll get to it. Okay. Think about it yourself, and then we'll talk about it. What would our next step here? Yeah. Divide both sides by negative 5. Cancel that coefficient out. And negative 20 divided by negative 5 is positive 4, which equals x squared. PEMDAS people, they start to freak out because they don't know what to do next. PERMDAS people, we do. What do we do next here? To undo an exponent, you take the root of that term. The root of x squared, those operations cancel out. The root of 4, x equals 2, but because it's a parabola, x also equals negative 2. Okay? If you want to shorten that up, you could say x equals positive and negative 2, like that.
It was on my desk.
Meaning, folks, Owen, Nathan, and again, what we solve for here, what this means is that our parabola, when we graph it, is going to cross the x-axis at 2 and negative 2. Okay, that's what we're doing here. That's what we're solving for. We're finding the x-intercepts of the parabola. Okay, Paisley.
I'd just like to say, Mr. Schultz, I appreciate you for teaching us this.
Well, thank you, Paisley. You can thank the state of Minnesota for putting it in the state standard. But I appreciate you for appreciating me. Tristan.
Will there ever be an equation for its math solution in this form?
No, this format will always have 2 solutions. It'll always be opposite values. Yes.
I appreciate you for being captain.
I appreciate you for being my crew. Cool.
A discussion.
Oh, very good. You don't appreciate me?
No, I do.
Oh, good.
But I don't. I kind of don't because you like.
Try the last one on your own to see what you can come up with. Maybe you've already done it. If you haven't, give it a try. We will. Folks, if you've done the third one, flip the page, start working on those there.
Is it the same thing?
It's the same thing.
It's like actually like the same thing. Same equation setup. Thank you.
It's different methods.
Right away?
Yeah.
Oh, never mind then. No,
Oh.
go to the next page.
I was gonna
I
say.
thought I put more sample problems on.
be done?
Who wants to share? Who's bold, brave, courageous? What you get, Nick? Yes.
I added 72 to both sides.
Okay. So start by, again, setting this equal to 0, adding 72 to both sides. 72 equals 8x squared, and then divide both sides by 8. 9 equals x squared, and then root both sides. And what do you get for x?
3 equals x and -3.
Good. 3 and -3 are your values for x. If you want to shorten that up, you could use the plus minus symbol, x equals positive and -3. Okay. I would like you, any questions on this before we go on?
No.
I like it.
Good. So go to part 2. Part 2 is where we have some more practice problems here.
Are we
Okay.
sure it's like the same one?
And I would like you to just practice these 3 for tomorrow. Okay. Now,
This is homework?
just those 3. Now, the second one always throws people off, okay? Because you're like, wait a minute. There's already a number on both sides there, okay? But if our goal is to get x by itself, even though this doesn't equal 0, that's okay. What would our first step still be?
-80.
Move the constant over. Whether this is a 0 or a 480 or whatever it is, your first step is to move that constant over. Once you do that, subtract 80 from both sides, now it looks very similar to the other ones that you did for practice. Okay? So this first one, an equals 0, that looks exactly like the one that you did for practice. This one equals 480. It looks a little bit different. This one looks a little bit different as well, but the first step is always move that constant over. It doesn't matter what's over on the other side. Okay, move that constant over. So just these 3, work must be shown, just these 3 for tomorrow. Okay, Sam.
How do you do this on a calculator?
So if you've got the recommended calculator for the course, can I borrow this, please? If you've got the recommended calculator for the course, the root key is above the x squared button next to the 7 there. So because it's it's not on the button, you have to press the second function first. Okay? So to do a root, you are going to press the second function button.
I tried that.
Then you're going to press the x squared key because what you actually want is the root symbol that's above that. Okay? When you do that, it's going to give you this. It's going to give you a root symbol with a parenthesis.
Yep.
So if you're taking the root of 100, which is what you end up doing in that second one there, you're going to second x squared key, push in 100, close your parentheses, and then it will only give you the positive value. You need to be smart enough to remember there's the negative value as well. All right? All right. Other questions, comments, concerns, complaints, compliments, congratulations, or criticisms? Cole.
Why does Canada have milk in days?
No idea. We do too, though. You ever been to like a Old Griffin Bay or a Golden Corral?
Wait.
The milk comes in bags. Good shit too. There you go.
What about powder?
When you go to Canada,
Powder milk? That's what formula is for babies.
8.4.
Yeah.
You only have to do the top 3.
Yes, only the top 30 for homework tomorrow. Let's play the number game, people. That's how I math.
don't forget to like and subscribe.